Assalamualaikum warahmatullahi wabarakatuh. Before we start the class, please read the rule for the participants. First, please turn on your camera and turn off your microphone. Second, please change your display name for the Zoom with the format. And third, please behave appropriately during the guest lecture. Fourth, the question can be asked by chat menu. And fifth, do not forget to subscribe YouTube channel Fik UNES Semarang Official and Kesmas UNES. Six, in the end of this lecture, it will be informed the URL of the e-certificate issuance. So do not leave the Zoom. And the link is active for only 60 minutes after this guest lecture is over. Assalamualaikum warahmatullahi wabarakatuh, and good morning in Taipei to our honorable guest, Professor Shabbir and all of my colleagues and students at Public Health Department, Universitas Negeri Semarang, Indonesia. Welcome to Health Data Management course. My name is Dina. It is my pleasure to be a moderator for this session, and I'm glad to welcome Professor Shabbir from Taipei Medical University, who will present application of artificial intelligence in the healthcare.
Okay, Assalamualaikum. I can start right now, right?
Yes. Before we start, I will introduce first.
Please go.
Okay.
Also, please give me permission to share screen.
Oh yes. Okay. Okay. Mr. Lukman, please manage the screen share after this introduction. So, before the presentation begins, allow us to introduce our guest lecturer, Professor Shabbir graduate with PhD degree in Health Informatics from National Yangming University. And he is professor at Graduate Institute of Biomedical Informatics, College of Medical Science and Technology, Taipei Medical University, Taiwan. Professor Shabbir also got many scholarships, publication research award, and patents. He has more than 100 research publications and guest editor of prestigious journals. His research interests are artificial intelligence, big data, wearable technologies, and health informatics. And now please welcome our special guest, Professor Shabbir. The screen is yours.
Thank you so much. Okay, please let me know once you can see the screen.
Miss Dina, would you please close your share screen first?
Okay.
Can you see the screen?
Not yet. Wait.
Yes?
Not yet.
Dina, can you see my screen, please?
Okay, we can see your screen, Professor.
Perfect. Okay, so once again, Assalamualaikum. Let me get started. Thank you for organizing this talk and inviting me to share my experience in the field of artificial intelligence in healthcare. As you know, I think this is my third or fourth year of giving guest lecture for you guys. So I am very glad to be again here, and inshallah hope next year I will be in person there. Let's see how things move. So before I start, just I need to know how much time do I have, Dina?
Okay. So it takes like around 60 minutes for the presentation and around 40 minutes for the question and answer.
Okay, perfect. Okay. So I may not...
Professor, would you please share again because we cannot see your slide.
Okay. 1 minute. I don't know what's happening. Okay. Can you see now?
Yes, I can see your Google Scholar.
Okay.
Okay, yeah,
Perfect.
huge screen.
So let's get started again. Okay. So without again wasting time, let me jump into the presentation. And I hope my audio also is clear. Wonderful. My audio is clear, right?
Yes, clear, Prof.
Wonderful. So let's start with this topic of artificial intelligence. But before going to the presentation, definitely I would like to know the need of AI, especially in this COVID-19 era in healthcare, why we need a lot of artificial intelligence to be in place. So first thing, I hope all of us will agree that our lives have changed before COVID and after COVID. It's not only the way we are behaving with our colleagues or friends, it's about everything, how we are living our life, how we are purchasing, how we are doing shoppings, how we are celebrating our festivals. Everything literally has changed. At the same way, education changed, healthcare changed, business changed. So now we prefer a lot of digitalization and e-commerce and all those using online stuff. So therefore, healthcare also become online as much as possible. We need to remember that. The next thing is definitely now we don't want to do unnecessary visits to the hospitals. Before it was like whenever you want, you go to hospital, have a chat with your doctor, but now it's not possible. It's not safe for you and for doctor both. And many hospitals are like closed. They only allow you only when there is need for you to see the doctor. Otherwise, they want everything to be done online. And therefore, we want to introduce or we want to practice this 4P medicine, which is prediction, prevention, participation, and personalization. So now I will try to see how we can bring all these 4Ps using AI. For number one, when we use remote monitoring, because obviously if we cannot go hospital every day or often as we used to do, then there should be some method by which we need to monitor our patient. Because one thing I want to make clear, COVID is not only one disease in the world. There are more than 10,000 diseases. If you go by like ICD classifications, more than 10,000 diseases. So why we are only worried about one disease? What about rest of 10,000 diseases? Therefore, we cannot ignore other diseases. We need to monitor, we need to keep in our eye on those type of diseases, and especially complex diseases like cancers, like chronic kidney disease, like stroke, you name. There are so many diseases where we need constant monitoring of the patient. Once we agree that, definitely you need to also agree like we need remote monitoring and we need a methods to interpret clinical data which we collect from the patients. So one of the research domain which I am interested is wearable device. We use wearable device. We give watch, smartwatch, or we give Fitbit or any type of device which can collect data from the patient, such as physical activity, heart rate. By these two parameters, we know can know a lot about what is happening with the patient, whether the patient is deteriorating, that means he's going down, or he's improving, or he's maintaining status quo. It is all depend upon how much he is moving, how much he is sleeping, how is his heart rate. By seeing all these things, we can know. That's why we say remote monitoring and interpreted clinical data. And we can use a lot of predictions using, okay, what is happening with the patient. The other thing is long-term care of chronic diseases, as I told. There are not only acute disease, this is not only COVID, but there are so many thousands of chronic diseases, diabetes, hypertension, myocardial infarct, so many, to name a few. Cancers are there, so many cancers are there. Therefore, we need long-term care management. In order to do long-term care, again, we need to collect information, because as I told, patient cannot go to hospital every week or every month even. We don't want, unless until the patient really need a physical visit. So in order to do this long-term care, still we need what you say, data, and we should personalize his care. It's not like everyone we give same care. Those who need often visit, definitely we need to call. Those who don't need, we need to avoid them calling, asking them to come to the hospital as early as possible, meaning whenever necessary. Then comes teleconsultation from home. Because another way, if we don't want them to come hospital, the only way remaining is, see, we cannot ignore them. Then we need to see them at their home by using, like now we are doing. I am somewhere very far from you guys, and you can see me, you can hear me, you can understand what I am saying, and same thing applies to me. If you talk to me, I can definitely understand what your questions, then I can reply. It says recording stops, but that's fine with me. And the fourth thing is ensuring continuity of care. Continuity of care is nothing but we cannot stop once the patient goes back to home. We need to keep monitoring, keep giving care to the patient so that we prevent complication. Okay, prevention is nothing but not allowing patients to develop complications. If the patient has diabetes, there are so many complications if we don't take care of the patient at the right time when the disease is minimal, like diabetic retinopathy, diabetic nephropathy, diabetic neuropathy. So these are complications. Therefore, we need to monitor, we need to have long-term care so that they don't develop any complication. So once I make these things clear, then it will be much easier, the examples what I am going to present, where we used AI. That is the whole idea of this presentation. Although I have more than 25 to 30 studies only focused on AI, but obviously I am not going to discuss all the 25 diseases, but I do it on around 8 to 9 diseases. Okay, sorry. Okay, so let me begin with the current issues of healthcare where we can use AI. So number one, medical errors, that is related with patient safety. So I don't know how many, I think most of you are from healthcare background, then you will understand what I am talking. If the people know how much errors are happening in hospitals, they fear to go to hospital. And it's not like healthcare workers, they are lazy or stupid. No, it's not like that. It's because of intensity of information we need to handle at the hospital and the long working hours. We are human beings at the end. We need to understand. So we get tired. We have emotions. We need sleep. We need to eat. So taking care of all those things and a huge workload, definitely there are possibilities of doing some sort of mistakes, and which is very harmful for patient safety. Right? Therefore, we need to use some sort of AI or informatics tools which help both physicians and nurses and care providers. So we will give the examples, what are the various type of tools which we can use, which can help in mitigating, eradicating this type of errors. Then comes poor and inconsistent quality of care. Again, same reason that we are human beings, we are not robots, we need our own space, our own time, we need time to take rest, we need time to sleep, we need time to eat, but patients are so much, working load is so much, therefore, again, it may affect our quality of care when there is a lot of patients to take care and less manpower. And the third thing where we can use AI is this one size fit all or generalized medicine. Currently, we practice generalized medications or generalized healthcare. What that means? That means if the patient comes with same problem, like 100 patients comes with headache, we provide same treatment for all these 100 patients. We assume, okay, let's start with this drug. If that doesn't work, go to the other higher one. If that doesn't work, go to the more higher one. But that is not the correct way of practicing. We need to know more information, allergies about the drugs, and then we should prescribe appropriate drug to the patient so that they don't need to waste time, suffer longer time, so that, okay, doctor, this is not working. I was taking from the last 3 days. Then you say, okay, then start this one. That's not the way to practice. So we should not practice all size fit, one size fit all method of healthcare. And other things, when you see your lab values, it is again one size fit for all. If it is female, male, children, adults, older people, we have same values for everyone. That is also not correct. So now we have AI models, we have data collection, we can personalize our own values. So the HB for me may not be exactly for you, or blood pressure for me should not be same for you. It's my body, so I have my own value of my blood pressure. So you cannot say like, okay, 140/90 is the value for everyone. So this is what we are practicing now. The normal blood pressure for now is 140/90, which is not correct because everyone has their own value of blood pressure. So we need to know when we can know the only when have large number of values of my own blood pressure, then the doctor can know, okay, usually for him it's 110/90, 110/86. So this is my normal. So if there are plus and minus 5, then that is going up and down. It's not like 140/90. And it has to differ between males and females, children, adults, older people, but now we are practicing same. So these are the key issues, I think, where we can use AI and we can make personalization, predictions, preventions, so that patients don't suffer so much. If these things are clear, because these are the foundations of my presentations, if you understand this, I think 50 to 60% of presentation is done already, because this is exactly what I want to show you by giving some examples. So before going to examples, I want to give some more clarity on what is artificial intelligence. It's not like something new we started this year or last year or 5 years. Artificial intelligence is since when we have computers. It's last 50, 60 years we are using, but different formats and different this because of computation power and data we got available. You need to understand only we getting in unprecedented amount of data in last 10-20 years. But before it was not the case. Before it was like we used to get very minimal digital information. I mean, we used to have paperwork, but with paper records, you cannot do AI. In order to do AI, you need to have digital data. So what we used to do was, without using data, also we can use something called rule-based inference models. There, we don't need data. Only what we need is some values. Okay, if you are female, if you are above 50 years, you need to do mammogram for screening of breast cancer. So now what's happened? It doesn't matter you need it, you are at risk of it getting breast cancer or not. The computer, if you are using computer and if you key in, okay, the patient is female above 50 years, automatically there will be alert saying, okay, you need to have mammogram. In the same way, if you are using some drugs, then they will be alert saying, okay, please check your blood creatinine, serum creatinine. Why? Because the drug will be acting on the kidney. In the same way, if it is on liver, they give you, if the drug is acting on enzymes, then it gives, okay, check your liver function. So this is called rule-based inferences. Then when little bit more information and more clinical data we got started getting, then we moved to probabilistic inferences. Probabilistic inferences is not, it's pure statistics. It's the Bayesian theorem. If you know about it, it's all about probability of chances of occurring something in together compared to independent. So if the patient has diabetes, what are the chances of the same patient having hypertension? Then how we do that? We see how many patients will have diabetes and hypertension divided by how many people having the diabetes and the hypertension independent. That gives you odds of what are the chances of patients of having this disease if the patient have another disease. Or another simple example is, okay, if you just monitor students entering the classroom or students sitting next to each other, you can easily make out who are friends of whom, because these two students sit together most of the time. Simple example. Same things, disease also occur like that. They occur together. They don't occur separately. If they are occurring separately without any combination, then they are totally independent diseases. But if they occur most of the time together, then there is an association. There is a bonding between these diseases. There is some causal relationship. This is causing this or this is causing this. These things we need to understand. Then comes statistical models like regressions, all those ANOVA, all those things where we can very easily make, okay, what are the chances of getting this disease if they have this? Then the fourth one is ad hoc scores. There are so many scores used in clinical practice to make the things easier for clinicians to take immediate decisions. Okay, you know, maybe Glasgow Coma Scale. You see, okay, if there is opening of eye, whether he's reacting to the comments, whether he's moving the arms, no, then okay, this is the value, then this is the outcome. This is how we used to work. Then slowly, again, when the data got increased, when we were collecting huge number of digital information, then we started training the models. There comes machine learning, there comes support vector machines, forest, random forest. There are like another a few 50s to 60s different techniques. These are all techniques to teach computer to help us to make decisions. And then I will talk a little bit about convolutional neural network. Convolutional neural network is nothing but it divides the image Usually, convolution neural networks are worked with the images. We call image processing. What is image processing? Image processing is nothing but any image you give to the computer, it divides into pixels. All our displays are functional units are pixels. So they divide all our screen into pixels, and then they start seeing neighboring pixels, change in the isolations, change in the color, and then they make a patterns. So in this example, we have given like say 1000 images of cars, only cars, different colors, different shape, different angles, from front, from side, from back, from up, from down, from angles, every position, like 1000 images we have given. Then the computer will remember all these 1000 into pixels, few millions. So all these millions of images are stored, and they know all this is cars. So next time when you show motorcycle or bike or trunk or train or aeroplane, then computer know whether it is car or no car. Simple. And then same thing, same principle we use with the diseases. I show 1000 images X-rays of tuberculosis. Then the computer knows how the tuberculosis looks like, because usually they have some patterns, some trends. So those things are memorized by the computer because it has so much computation power and memory power. Right? Then that's how it works. See, at the end, if you show car, then it says whether it is car or truck or van or bicycle. So this can be our outputs, a multivariable, or it can be only two outputs, car yes, car no. Same thing. Now change this into diseases. You put tuberculosis or cancer, then it says cancer yes, cancer no. But if you give cancer, tuberculosis, amyloidosis, all various type of diseases and save them accordingly, then the computer can distinguish whether it is cancer, whether it is tuberculosis, whether it is infection, whether it is some other disease. So this is the ground picture of background of how AI and convolution neural network works. Now I will give example of around 8 to 10 different studies so that you get clear-cut understanding of how AI can be used at large scale, at population scale. So the first example which I want to give is My Health Bank. So students who are from Taiwan or know about Taiwan healthcare system knows about what is My Health Bank. My Health Bank is nothing but it is from National Health Insurance Bureau, which is the single payer system of Taiwan healthcare providers. No matter where you go, which hospital you go, private, public, university hospital, or general physicians, even Chinese medicine, dentist, all your data will go to one database. That is the beauty of this database and Taiwan National Health Insurance Bureau. So we have like 23 million population in Taiwan, and the National Health Insurance is collecting data from last 30 years for 23 million population of. So it have this thing, what you say, data of each and every individual, their disease comorbidities, their lab values, their images, everything. Experience from Taiwanese National Health Insurance research data demonstrate that cancer patients have a specific disease patterns, and patterns can be discovered from electronic health record longitudinal data by machine learning models. The model can predict cancer risk according to the medical history of the clinical diagnosis and the medications and image values available in the data set. Okay, now we have specific disease patterns discoverable from EHR longitudinal data. Then we use machine learning in order to process these two things and come up with risk of, currently they are doing risk of cancer, liver cancer, and risk of chronic kidney disease. And here they do personalized prevention and cancer prediction from medical history of clinical diagnosis and medication. So again, how it works. These are all our variables: age, gender, what are the comorbidities the patient is having, what are the medications the patient is using, what are the lab values the patient is having. All this goes into hidden layers, and at the end they come up with, okay, whether they have liver cancer, they don't have liver cancer. This is the bivariate outcome. So we say whether the chances of cancer, yes, no. And this is my own information. Then they see, okay, male, female, age, SGPT values, ALT values, and what is this? Antigen, hepatitis C antigen is there or not? Then they give a risk. So for me, it is like 1 to 10 percentage. So I have very minimum cancer risk in next 10 years. So this will change by age and by our values, then the risk also will change here. So that is how it works. We tried to do similar things in India, where we wanted to integrate AI models for our biggest online consultation platform, Sanjeevani we called, where we wanted to predict early risk prediction of cancer, care and support to cancer patients by using wearable device. So basically, this is the model we wanted to follow. We use wearable device to collect data from the patient. Then we use mobile app to collect subjective information from the patient. Then it goes to the server. Then we have clinical data from the hospitals. When do all these analytics, then we provide some assistance or some aid, some suggestions to the clinicians how to take care of the patient. So this is how it works. To scale up existing health record to artificial intelligence based personal health for risk prediction, understand the cause of cancer, develop model to compute risk of developing cancer, and develop IoT based solutions. IoT means Internet of Things and wearable device based solutions. And my third study is a crowd health, which was European study. It is all about holistic health record, big data analytics for policy making and personalized health. So in this project, what we wanted, definitely we had so many partners all over the Taiwan. And of course, TMU is the only partner out of Europe from Asia. And this is the snapshot how it looks. First, we get information acquisition. That is from heterogeneous data sources, from electronic health records, from wearable device, even from your social networking information. Then we do collective knowledge, and this is called social holistic health record. In short, we want to provide data-driven evidence, because right now we are focusing on clinical trial or evidence-based medicine. But for evidence-based, for each evidence, we need to have separate trial. And clinical trials are so expensive, time-consuming, resource-consuming, and you can solve just one problem at a time. Therefore, we want to come up with data-driven evidence where we can collect holistic data from the patient and try to solve a lot of different problems with provide solutions. At the same time, we wanted to get data-driven policy making. To get familiar with the terms and concept, we are using these things so that you understand what this thing means. See, data driven, all those things. Data value from chronic disease, health centers, social networks, lab values, public environmental or exposomes information, all those things we include. Then we make, you see, it's very complex where we use lot of different modules to communicate with each other so that we can make very reliable information. So this is the architecture behind how it works. Definitely, you don't need to know the details. Just to give an idea of how things work. So we had 6 different pilot cases in this project, and TMU was interested with chronic kidney disease, where we want to predict patients who are going to develop chronic kidney disease by seeing their comorbidities. And at the end, as I told, we want to make public health policies using the data of various heterogeneous this thing. So what happens? Collective wisdom driving public health policies. Right now, we are focusing on several health services, limited data exploitation, inefficient personalization, because I talk about this inefficient personalization because still we use generalized practice of healthcare. And health records are there, but they are in silos. Every hospitals, they have their own EHR systems. They don't communicate with different hospitals. Inefficient, untargeted, and fragmented health policies. But with this, what we want to do is heterogeneous data source integration, holistic health records, data analytics on aggregated data. That means we are not making our decisions using separate data sets. We are communicating, developing our multi-model target policies in terms of time scale, location, population segmentations, and evolving risk. So this is the project, and there are some examples which I want to provide. For example, we wanted to use machine learning models to predict initiation of hemodialysis, which is called renal replacement therapy among kidney disease. Here we try to use a national health insurance database. We collected patients who got kidney disease. Then we went back to 1 year, and then we see, okay, what are the risks of developing kidney disease in next 3 months, 6 months, and 12 months. Then we started patients without RRT. RRT is nothing but hemodialysis, and with RRT. So short thing is, once the patient get chronic kidney disease, we want to predict whether the patient is going to get into hemodialysis, because hemodialysis is lifelong procedure, very expensive procedure. All the cost is borne by the national health insurance. Therefore, it's very important for us to know who are the candidates who are going to get hemodialysis. 12 months ahead is perfect, because accordingly, either we can give more importance, more attention, and we prolong the onset of getting into hemodialysis, or we can provide better or early detection where they need hemodialysis. Okay, so this is the whole this thing. We make a model on this. As you see, patients data. First time he got the diagnosis of CKD, then we are seeing prediction time in months. It can be 3 months, 6 months, 12 months, and then we see what happened with the patient. So these are the different parameters values to evaluate machine learning algorithms. And we used various different tools. It's not just one model. And this you see, its value 77, 78. It's not perfect, but at the same time, you need to understand we are not using any clinical information. Only we are using comorbidities. So balance, unbalance, all this type of these things we managed to get into. And we got up to 79 of AOROC. Here 77, 79, depending upon these things, what to say, period. 12 months, 77, and we give our confusion matrix of 12 months prediction, and then analyze what are the top indicators. So abnormal blood chemistry, septicemia, iron deficiency, anemia, these were the indicators to see, okay, these guys are going into hemodialysis. And the conclusion was use of comorbidities to predict hemodialysis in predicting the chances of upcoming hemodialysis based on clinical data using predictive models on general population with the data available can allow better planning and allocation of the resources. And this was published in PLOS. The another disease which we use and publish in scientific report was about using artificial intelligence on complete blood picture to screen blood cancer. So here we used with South Korea hospital, and then we collected a data from analyzer, this midray, which gives your complete blood picture, hemoglobin values, platelet values, and what you say, there are so many indicators of simple complete blood picture. We use complete blood picture, which is very often requested by the doctors to screen. We are not doing diagnosis, just we are screening, saying, okay, this person has chances of getting what you say, blood cancer. Then they can go and have some specialized investigation on that. So the machine learning, this thing, okay. So in our study, the data description is following with 451 patients and 112 data included data demographics such as gender, age. The duration of collecting data is 2 months. It is IRB approved from the Konkon University. The location of study is Department of Laboratory Medicine, Konkuk University Medical Center. The diagnosis of patient in encoded in ICD-10 code, and the tool we used is hematology analyzer midray BC 8600. So these are the two phases: preparing the data and selecting proper machine algorithms and its hyperparameters. This is the routine procedure for any data, and now by this time you already aware these are the input variables, these are the hidden variable nodes, and this is our output. In our output, only two: whether the patient are risk of having blood cancer or no blood cancer. So these are the details, and these are the top 10 values like platelet counts, where the top indicator. At the same time, platelet count, optical impedance, age, and neutrophils, infected RBC percentage, and platelet count impedance. These are the variables which we use from this analyzer. And the value we got was 93%. So we got very high predictive value of screening blood cancer using simple blood test. This is the graphic AUC as applied threshold 0.05 with ANN in the top result with AUC 93%. ANN achieved the highest accuracy, precision, recall. with 82, 82, and 84% respectively. And the conclusion is ability to predict blood cancer and non-blood cancer malignancies with accuracy of 82 and 93%. Outstanding performance result on ANN model as the diagnostic ability of ANN achieve higher accuracy, precision, recall, and future use and application of NL models to complete blood count can be used for a quick first stage screening of data to detect blood malignancies or non-malignancies hematological diseases. And the third study is here we use non-contact sensors. Again, we use AI, but for the sensors data. So here it looks like this. This is the sensor which we keep under the mattress. We don't even touch the patient. And this is the values which we can see. This is the heart rate. This is respiration rate. And this is movement, meaning patient is restless or not. Where we use this? We use this for the patient who are undergoing hemodialysis. Maybe you know hemodialysis is nothing but circulating whole blood. For that, the patient has to lie down on bed for 3 to 4 hours. Why we use these patients? Because these patients are so much vulnerable for getting infection, for getting complications like heart disease, for getting spasm, clamps of the muscles clamps. So there are so many things these people are vulnerable. Therefore, we wanted to predict these 6 things. Sudden death is most important. Emergency visit to the emergency room, muscle spasm, inpatient admission, emergency visit, and no events. No events means the patient is healthy and they are doing good. So we use all this information to do this. As I told, we use these 3 parameters: respiration rate, heart rate, body movement data. And from respiration rate and heart rate, we got heart rate variability. Heart rate variability is nothing but the variance in the heart rate, which is the indicator of sympathetic and parasympathetic nervous system of our body. So this is like very sensitive information from our body. Whatever happening in your body, first thing that knows is your nervous system. Before, even if you get temperature, you get infection, you get any disease, the first thing that knows about your body is your nervous system. Therefore, we wanted to target the indicators of that nervous system, which is nothing but sympathetic and parasympathetic nervous system. Then heart rate variability is the parameter of this nervous system. And this is how we use non-contact sensors data, heart rate, respiration rate, and heart rate variability. Then we clean, we make model. And here also we got very high value of 90% to predict whether the patient is going to get clinical events or not. So these are the different models of different values. And as I told, we got like 90% with 96 mean precision and 88% of recall. And use of non-contact sensors in clinical setting to monitor vital parameters of patients. Development of early warning solutions using AI for prediction of clinical events. Assist healthcare professions in decision making and designing better care plans for patients by early detecting chances to vital parameters. So this was the third study. I don't know, how about you guys have any questions? You can type or you can just unmute and reply me.
Yes,
If you...
for the student who has any question, you can put into the chat box, or maybe you can raise your hand and I will give the
Yes, you
the
can raise
microphone
your
to you.
hand or you can type in chat box, whatever you want. Even if you don't have question, you can just type no questions, then I can proceed with my presentation because I don't want to keep on talking without knowing any feedback from you guys.
Yeah, or maybe if since you all of these audience most are public health students, maybe you have question related to AI for prevention, maybe because usually we do the prevention. Okay, there is one question from Nabila.
Better she can ask it because it's
Okay. Nabila, maybe you can unmute your microphone and you can direct asking your question to Professor Shabbir.
Okay, Budina. Okay, before that, I'm Nabila from Universitas Negeri Semarang. Thank you for Ms. Prof. Shabbir for insightful discussion. And I want to add something. We all know that AI for medical purpose is really useful and play an important role such for prediction of clinical events until for evaluating the risk of some diseases. But we can pretend that so much risk if we're not careful to use it. Is there possible thing to data leak happen? If there's any, how to handle that professionally? Okay, thank you.
if Nabila, thank you for your question, but if I understand correctly, you are talking about privacy issues of the patient, correct? Data leak of the patient's information, right?
Yes, that's what I mean.
Okay, no problem. Okay, whenever we do data analytics, we are not interested with the patient identity. We are not, because our computer don't need to know who is that, whether she is Nabila, whether she is Dina, whether she is Shabbir. That is not what the computer needs. Computer needs only things like age, gender, comorbidities, all those things. And then we are using this information to predict. So therefore, patient identity is not key, number one. Number two, whenever actually your question is more about on patient privacy when you are developing a IT system, it has nothing to do with AI. It has nothing to do with AI models. AI models are different. What you are asking is about patient privacy, security of the data once we input the patient information in the system. For that, definitely we have advanced technologies, we have very security technologies available, which will not allow very easily penetration or leakage or breach of patient's information. Understand? So we have safe technology. Short answer is we have safe technology, but the thing is that we should be careful. If you are reluctant, if you don't use the advanced technology, then there are chances of leaking the patient's information. Anything else?
Okay, Prof, thank you for the answer. So
Okay.
the purpose is to make sure our technology is
In place.
for public. Yes.
Exactly. Always we
Okay,
should keep our systems updated.
okay, thank you.
Mhm.
Okay, so for other students, if you have any question, you can raise your hand.
Okay, if no, I can continue to proceed. I have from here after I go a bit faster because basically I have given you the idea of what is AI, why we need AI, and what are some examples. So, but I have some more examples which I go very fast.
Yes, it's okay, Professor, because usually the student will apply for research grant every year. So your material will be give the inspiration for them to make some
They can
innovation.
come up with model. Yes.
Yeah.
So here, the paper which I am showing you right now is about sending motivational messages to the people who wants to quit smoking. And there we used AI to do personalized messages. Again, as I told, I never use generalized medicine, even for prevention. Here we use this app where it shows from how many days you are not smoking, how much cigarettes you didn't smoke in these days, and how much money you saved, and how much health you gain. At the same time, before we start using this app, we take questionnaires from you, your age, your gender, whether you are pregnant or not, whether you live with the pets or not, whether you live with the children or not, whether elderly people living or not. Then we connect you with your circumstances. That makes more personalized. Then it will be more interactive and more what you say, engaging. Then the people know, oh, okay, if I say, if I have 3 years baby with me, and if I get message, okay, you are not smoking, please keep it up. It's not only profiting you, but also your baby's health is improving. That is give me very good inspiration, motivation for me to continue not smoking. So can dynamically compute a list of recommended items for each users using AI. The type of machine learning provides users relevant information based on their behavior, similarities, and the people they are living with. And this was how we use, and we use recommendation depending upon their circumstances. And again, whole architecture is there. It's not as simple just you send whatever you want to the learners. In that way it doesn't work. So you see, and we also see at what time they see, what type of message they like, so that we can provide similar messages to them next time. So implementation and development process of health recommendation system using I change behavioral model to help people quit smoking, application of AI built algorithm to digital health solutions. And this study is to predict survival outcomes using wearable device among end-stage cancers. Here, if you know about palliative care or hospice care, patients come there with terminal disease. That means they know nothing can be done. They are only taking care for supportive care, and they are literally waiting when they can die, because that is nothing that we can make their improve. Therefore, we wanted to see the patient who got admitted in this hospice ward, they go back alive or they die in this admission. So evaluate and quantify patients' performance status, as well as to predict the survival of terminally ill cancer patients in hospice ward. We use wearable device. We collect 24 hours of data when they are at the hospital. In first 2 days, we can say whether the patient is going to survive or they are going to die. So this is the data, this is the device, and this is the data we get. And we got pretty much good, like 86, 96. If you use 2 days data, up to 96%, we can say the patient is deteriorating or improving. And if you use 1 day data, up to 93%, we can say he's deteriorating or not. So we use this Karnofsky performance status score to prognostic accuracy of 83%. And we use LSTM prediction model based on patients' continual actigraphy monitoring, and to predict end of life admission outcome in palliative care cancer stages. And this is predicting severe outcomes in COVID-19 related illness using only patient demographic and comorbidity symptoms. Here only we use what are the comorbidities of the patients who are getting COVID positive, and whether, because this, if you see, this was like 1 year back, and actually the data is the time when the COVID was at the peak time. It was so serious. People were so much worried about it, whether, because so many people were getting COVID, but we don't know whether they are going to develop severe illness and going to die, or they are going to recover back. So minimal crowding in hospital waiting areas, crucial to mitigate nosocomial spread of COVID. And remote triage tools, this was very important to decide whether we want them to come to hospital or we want them to take action at their home. So to demonstrate the value of information that can be collected remotely, prior to presentation at healthcare facilities such as symptoms and comorbidities, predicting patient risk of developing severe disease from COVID-19 infection. And this was retrospective and case control. Predictor variables are nothing but patient demography, symptoms, and past medical history. And then we got all this information. By seeing this, by having age, we can say, okay, how much percentage the patient is going to get what you say severe disease. You see, immunocompromised has odds of 2. Dyspnea is 2. So the more the value, the higher the complexity. Then we use this model to do the triage at their home. And the other thing which we used was black fungus. I am not sure. I think even in Indonesia, there were high peaks of black fungus for the patient who got COVID-19. In India, it was so much huge. Therefore, we tried to use artificial intelligence-based model to predict the risk of mycorrhizasis is nothing but black fungus among COVID-19 survivors from hospital data. So life-threatening and rare fungal infection, black fungus, increase the number of cases after COVID-19 infection. Then the aim of the study is to develop AI-based model to predict risk of mycorrhizasis among COVID-19 patients at the time of discharge from hospital after getting COVID. Then once they discharge at the COVID, we can know whether they are going to develop mycorrhizasis or not. And we got very good percentage of this, of 95% accuracy. So this was published in Journal of Infection, which is in fact factor of 6.02. Top 5 variables, positive impact towards the risk of mycorrhizasis is like obesity. Anomia is nothing but loss of smell. De novo diabetes is developing diabetes when you get COVID. Myalgia is body aches and nasal discharge. These are the 5 top symptoms which were at high risk of developing black fungus for the patients. Again, we used machine learning for chronic kidney disease using national health these things. Here we use who are going to develop CKD. And the last study where we use predicting length of stay and mortality among hospitalized patients with type 2 diabetes and hypertension. This is very common diseases, as I told, hypertension and diabetes. Then we wanted to know if the patient comes with one of these disease or 2 diseases together, what are the length stay and mortality of these people. And yeah, we use this data, NHI, and we got again a very good model of 89%, and we managed to get good results out of this. And we actually published in International Journal of Medical Informatics. You can just go and find this paper if you are interested. These are the highlights of the paper. Type 2 and hypertension place high economic burdens on health service. Length of stay in this hospitalized patient is poorly investigated. We used real world claim data to develop AI algorithms. The linear regression model performed well in prediction of length of stay. Multi-layer perception model performs well in predicting inpatient mortality. So I think these were the few things which I wanted to share with you guys. So I will be more than happy to take questions further. Thank you.
Okay, thank you very much, Professor Shabbir Sheikh Abdul. I hope all the students enjoy this amazing presentation. So now Professor Shabbir Sheikh Abdul will answer some question. For the student who have a question, you can raise your hand. Khairunisa, do you have any question? Hello?
Yes.
Okay. We will wait for the question from the student. Maybe I can ask the question, Professor. Since you have broadly experience work with another country like India, maybe since India is looks similar with Indonesia, that we have maybe still struggling to change the data from manual data to digital data. So can you share what's the challenge during your research related AI in India, and what can we do as a student to, if we want to start giving the technology as the solution in limited resources country?
Very good. Yeah, true. This is very interesting question. Definitely, as you told, both India and Indonesia are on similar page when it comes to implementation of health information technology. But again, giving the vast spread of our countries and limited resource, I think the key point for us is political willpower. If our health ministers, they are interested to implement information technology, things will be much faster and very easier for hospital people to get into. But if there is no political power, then it takes going to take long time. One. Then coming the second part of your question, like we as a students, what we can do. We as a student can make more research, can provide evidence to policymakers. See, this is going to work. Please use mobile phones for data collection. Then we get timely information from our community and we can take appropriate actions. I am giving again example of dengue or malaria from which is very common in our countries. What we do now is we use paper-based to collect data. We send health workers door to door to collect. By the time they collect data, they bring to their health center, then they do in Excel sheet. From there, it goes to district center. From district, it goes to the capital. It takes 3 to 4 months. There is no point of collecting data because this only use next year maybe, because we are not helping anybody right now. In that case, if you use mobile phone and you collect data and everything is going instantly to the capital, and the minister of people who are working under Minister of Health are observing what is happening day to day, right time real world data, then they can take appropriate actions so that we can save lot of life and money and resources at district level and at remote primary care center level. Hope I answered your question.
Thank you so much, Professor. Okay, we also interesting with your research related brain free smoking, because it's related much with the public health approach. So do you have any suggestion or further research related the free smoking approach with the
Okay,
technology?
for this, my answer will be like this. You need to choose right target population. If you divide all the people who are smoking, there are three types of population. One, you do no matter what, they are not going to quit smoking. They want to leave their wives, but they don't want to leave the cigarettes. So you cannot touch that people. Second group of people is they already have some health issues. They are having maybe COPD or maybe they are having cancer. Doctor already told if you don't do, you will die. So you again don't need to worry much about second group. There is third group. They want to quit. They know cigarette smoking is bad. It's not profiting them, but they don't need motivation. They lack motivation. They want to quit. They quit 1 day, 2 day, 1 week, then again they go back and start smoking. I think this is the population where we wanted to target. Then we start giving them motivation message, engaging them and making them adherence for quitting. Then they are best candidate for us to improve their own life and health. So please try to choose this. And obviously intervention, again, it depends from country to country, settings to settings, what type of resource you have, whether the users have smartphones or not. Then if they have, obviously now everyone has smartphones. So there are a lot of apps, solutions available which can be used.
Okay, great. Thank you so much. So inspiring. I hope all of the students you can gather some motivation from this material. So before we conclude this meeting, let's take a picture together. For all the students, you can turn on your camera. So we can take a picture together with Professor Shabbir. Okay, so wait a minute. I will take a picture. 1, 2, 3. Smile.
I think you give some time for people to on the camera.
Okay, okay.
So
We
now I
also
see
have,
more.
yeah, because we also have internet issue also.
I see.
Yeah, yeah. These are all my students, around 170 students. Yeah.
183, I see.
Yeah, yes. And also from other class.
Okay,
Yes.
good.
Yeah. Okay.
And I see so many female students. There are no male.
Oh, yes. In public health, around 95% are female. Yeah,
Good.
yeah. Okay. So, okay, are you ready? Okay, page 1, 1, 2, 3, smile. Page 2, 1, 2, 3. Page 3, 1, 2, 3. Page 4, 1, 2, 3. Page 5, 1, 2, 3. Page 6, 7. Okay, page. Okay, thank you so much, Professor Shabbir. We will conclude this meeting, and I hope we can meet you again in another course next semester, because usually I also will teach about health information system or health informatics, and hopefully we can meet you in Indonesia after the pandemic. Yes. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh. Wait a minute, for all of the participants, I will share the link to get the e-certificates. Wait a moment. Okay, so for the e-certificate issuance, please go to this link and please write your email address correctly. The e-certificate will be sent to your email address. The link is active for only 60 minutes after this guest lecture is over. Okay, can you screenshot or go to this link? I will keep around 5 minutes and I will close this Zoom. I also will check your presence for this session from this link. So your presence for the 15 online course meeting will be based on the data that you fill in this link. Okay, please keep the link or you can screenshot this screen. I will close this screen in 1 minute. I will close this meeting. Thank you so much. Have a nice day. See you again, inshallah, in the next semester. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Miss Dina.